Okay, before we start our session for today, I think you all know already, but I'll just inform you that we will not be going back to campus next week as planned due to the COVID cases now, like very worrying, right? So the management, Sabah branch management has decided for us not to go back to the campus for face-to-face session until the end of February. And then after that, we will look at the situation again and see what to do next, if we need to go back to the campus or not. Okay, so I think all of you know already, right? You don't have to go back to the campus next week. Yeah, so we will continue online learning for now. Okay. Um, may I ask, did anyone record our session for last Friday session for the no, not last Friday, not last Friday. Yes, for the practical session. Did anyone record the session? If you have a recording of last week's session, hold on. Yeah, the practical session. No, we don't have practical last week. Uh, week two, week two, week two practical. Did anyone record? If you have, let me know. Yeah. Noel. Noel, if you have letter, you share to me. Okay. Week two. Okay. Thank you. It's not here yet. And some of you is not here yet. Your friend, some of them not here yet. Maybe we wait for 2 minutes, then we start. Okay. So I will be recording this session today, but not using Google Meet recording. I will provide you the recording later after we finish our class today. Do you have any question before we proceed to start our lecture today? Yes, Noel. Week two, lecture you have ka? Lecture, lecture, we have the recording for lecture, I guess. And later I check again. Later I WhatsApp you lah, Noel. Okay? Okay, Farah. Okay, so can you start for our lecture session? Are you all ready? Hi, Kelvin. Okay, so I'll start recording as well. So this week is week 4. Okay, so this chapter we should be discussing this last. We will be discussing chapter 3 for today, data modeling for this subject BSCS 3183 Advanced Database Management. Okay, so we'll discuss on data modeling today. So first, let's look at the objectives or the learning outcomes for this chapter. So these are the learning outcomes that we should be learning today for this chapter. So the first one, we will discuss on the types of data models. We will compare and contrast type of data models that we have, and then describing the concepts in conceptual modeling. And then the last part will be describing the main concepts of relational data model, and then we will also discuss on object-oriented (OO), and the last part would be semi-structured data models. So basically, we'll discuss all the theories related to these keywords here. We look at data model, conceptual modeling, relational model, object-oriented or also known as OO, and semi-structured data models. Okay, so we go to the first one. We describe what is data modeling. Okay, so database design, it focuses on how the database structure will be used to store and manage end user data. Okay, so in order for us to design a database, the first step is to do this data modeling. So this is the first step in designing a database. So it refers to the process of creating a specific data model for a determined problem domain. So basically, every time you want to create a design, create a database or design a database, we will need to know what's the user requirement, or user requirement is usually the problem domain for the environment that we want to create the database for. So we need to understand the problem domain, and then we do the data modeling. Then we can design the database. Okay, so it is the process of creating a specific data model, typically for an information system. Okay, so if you have an information system like for a pet shop, a library, right? So you will have an information system to deal with the database. Okay, so we create a specific data model according to where the information system will be used. Okay, so this data modeling, it's an iterative, and it's a progressive process. So it always change according to the needs of your end user. So basically, we will start with a simple understanding of the problem domain, which is the end user requirement. And as your understanding of the problem domain increases, so does the level of detail of the data model. So every time like you gather information from your end user, you will also increase the level of the detail that you have for your data model. So if it's done properly, if this data modeling is done properly, the final data model, it will contain all the instructions to build the database. Okay, to build the database that will meet all end user requirements. Okay, so you need to understand what's the problem first, or what's the end user requirement. Then you can design, or then you can start to design the database according to the data model that you get. So this, like for example, here we have this student table here. You have the student number and then the student name. Okay, so what do you need to do with this student? Okay, you need to know what is the domain. So this is for class enrollment. Okay, so you will have another table. So inside the enroll table, you will have the class code. What is the class code? For this, it's for the student to enroll, also the student number, and the function is to enroll grade, and it's also this enroll information. It will be also found in the class class table, which this class table includes the class code and the attributes or the details of the class code. Okay, so you have the class section, you will have the course code, the class time, the room code, and also the professor number. So this professor number is maybe the lecturer information. Okay, so basically you need to know what the database for, then you can design the database according to your data model. So this environment here is for course enrollment for student at a college or university. Okay, so these are the definition of data modeling. So it's the first step of designing in a database. Okay, so let's look at the next one. What's the importance of data model? Okay, so data model, it can facilitate interaction among the designer, okay, you as the database designer, as well as the application programmer, the information system programmer. It can be the same with the designer. The designer and the application programmer can be the same person, and also, of course, the end user. Okay, so this data modules is very important so that you can have interaction between all these three personnel here: the designer, the applications programmer who implement the information system, and also the user, our end user. So a well-developed data model, it can improve or it can foster improve understanding of the organization for which the database design is developed. Okay, so this if it's well developed, this data model is well developed, it will give the end user the overall view of the database, like everything. Like for this example here, you can see that this system is for enrolling student into a class code, and then it will allow organization of data for various users. Okay, so you can have other user than student. You can have a lecturer, or you can have admin, and so on in your database. So it is also an abstraction for the creation of good database. Means you design your database according to a data model so that you have a structured database. Okay, so a data model here is in other words, it's a relatively simple representation. So it's usually graphical like this, or more complex real world data structures. Okay, so you can have this data model to simplify your database representation. So here the model here refers to the abstraction. Okay, abstraction of this one, abstraction of your real world object or event. So this data model will help you to understand the complexities of the real world environment. So just imagine if you like have this university system, you have enrollment for classes, you have enrollment for semester, you have enrollment for co-curriculum, you have enrollment for clubs, and so on. So using this data model, it will help you to give a simple representation of your database system. Okay, so more into detail on data modeling. So data model, it's a collection of concepts. Okay, collection of concepts which within a database environment. This data model, it represents the data structures and their characteristics. Okay, the structural part of your database. Its manipulative part, which refers to the types of operation that are allowed on the data. Okay, what are the operations that you can do on the data, and then it can also include a set of integrity rules. Okay, we have discussed about integrity. So for this data model, it also includes what are the set of integrity rules. This one is to ensure that the data that we have is accurate. Okay, so integrity always refer back to the accuracy of our data. So this data model will ensure that integrity rules is set to make sure our data is accurate. In other words, data model, it represents the characteristic of our data, the operation, what you can do on it, the constraints, the transformation, and other construct with the purpose of supporting a specific problem domain. Okay, so here we have another example. We have a branch number, we have street, city, postcode. So these attributes are the characteristic. Okay, the attributes is the characteristic or the things, the data that we have in this branch table. And then we have the relation, we have the degree and the cardinality. So this one we will discuss in detail later in this chapter. Okay, so before we go further into our types of data models, so let's look at the evolution of data models, a little bit of history on data models. So this figure here shows you the semantics in data model. Okay, so in the evolution of this database management system, the evolution of DBMSs has always have been driven by the search for new ways of modeling increasing complex real-world data. So our data year by year is getting complex and complex and complex. Okay, so we look at how it gets complex up until big data. Okay, so each new data model, it addresses here, this one, the data model, we have the hierarchical network and so on. So these are the data models. So each of the new data model, it addresses the shortcomings of previous model. Okay, so here from hierarchical to network, so it was improved to relational model and so on. So let's look at the first two model that we have. So 1960 and 1969. So we have the hierarchical and network model. So it's difficult to represent many-to-many relationships using this model. So we look at the example of this letter, and it has the structural level dependency, and it has no ad hoc queries. So you record at a time access, and access path is predefined. So you have a navigational access. So the researcher or the database designer, they discovered a relational model later in 1970. So this relational model, it offers several advantages over the hierarchical and network models through its simpler data representation. So it's conceptual simplicity, it is structural independence, it supports superior data independence for relational data model, and it provides us with easy to use query language, okay, ad hoc queries, which referring to SQL language. Okay, so in 1970s, where they start using this SQL language. So these features have made it the preferred data model for business application during this time and up until today. Okay, so it also set oriented access. So you can set access, who can access this data, So this was the still preferred data model now. So we look at how it evolved in this figure here. And then after relational, we have the entity relationship in 1976. So this one is easy to understand. It's more semantic and it's limited to conceptual modeling. So we will discuss on conceptual modeling in detail later. There is no implementation component here. It just present us with the entity relationship, the database relationship that in database design. Then later in 1978, 1985, 1990, we have the semantic data model. Okay, so it provides more semantic in data models, and it supports more complex objects, and then it supports inheritance. Okay, we have the class hierarchy, so it's the OO, object oriented. Also, we have the extended relational or DBMS. It also refers to the behavior of our data in our database, and uses XML, which is unstructured data, and also XML data exchanges. Okay, so I want to note on this OO model, that object-oriented data model. So it was introduced to support for complex data within a rich semantic framework. Okay, so we'll discuss more in detail about this object-oriented later on. So the ERDM, yeah, extended relational DBMS, it added many OO features to the relational model. So it takes the relational data model, added with the object-oriented features, so it becomes extended relational DBMS. So this allowed it to maintain a strong market share between business environments. So it combines the characteristic or the simplicity of relational data model with object-oriented. So this is, we call it ERDM, which is more preferred for business environment. And then we have 2009, we have the big data. Okay, so I think all of you know what is big data. This big data phenomenon has stimulated the development of alternative ways to model, to store, and to manage data that represents a breadth with traditional data management. So up here we have all the data model. All these are considered traditional. Okay, it refers to the relational data model, most of it. And then for big data, we are focused on NoSQL. Means it does not use SQL queries. So from here, from 1970, the relational data model, the database technology all less depends on SQL language. Okay, so later in the course, I think at the end of our lecture, we will have a topic on NoSQL, which we will be discussing on big data. Okay, so this data model, it addresses big data problems. Okay, so we look at what are the problems in big data later on, and then it is less semantics in data models. It is based on schema-less key-value data model, and it's best suited for large, sparse data stores. So if you have read about big data, our internet is evolving. There are a lot of new data, especially like you want to include a picture in your database, you want to include video and all the graphical representation you want to include in your database. So SQL cannot do that. So that's why we have this NoSQL technology. Okay. So next, these are, so here we already discussed about the little bit of history on data model that we have in database environment. So note here that 1983 the internet was born. So that's the time when we have the object-oriented data model, and also the extended, which combine relational data model with object-oriented. So next slide, more on data modeling. So the standard. Okay, so this is the standard that is responsible in defining the framework for data modeling based on the decrease of data abstraction. So this one we already discussed last week. So this organization, so it's in early 1970s, the American National Standards Institute, the NSI, it defined a framework for this data modeling based on the degrees of data abstraction. So the resulting architecture, it defines 3 levels of data abstraction. So the data abstraction here is referring to the external view, the conceptual, and also the internal. Okay, so this one we already discussed last week. So you can use this framework to better understand the database model. So this is the database model. So it actually refers to this data modeling that is defined by this organization here. So in this figure here, this part, so this framework by NSI Spark has been expanded with the addition of a physical model. Okay, if you notice here, we have the physical model at the bottom here. This is to explicitly address physical level implementation details of the internal model. Okay, so here the data abstraction here, it is referring to the data itself. Okay, so here we have this figure at the right hand side. It's the framework for the database model. Okay, database model. So we have the external model. Okay, we have also external level here. The view. This is the end user view, and then we have the conceptual model. So usually the designer view is here, refers to the conceptual level, and then we have the internal model, which is the database management system view. Here we have the internal level, which refers to the database framework. Okay, so and then for database model, there is an addition of physical physical model. So most modern commercial DBMS are based on this framework. So our Oracle SQL also refers to this framework. Okay, so we'll discuss in detail about this database model, this part. Okay, so the next slide, we'll discuss more on that. Before we proceed, we take 5 minutes break.
Okay. allow you to record on your side if you have any recording definition number. Do your own reading.
Okay, can we continue? Okay, so we continue, yeah? So let's look at more on data modeling. So this is the database model of our data modeling. And, check something. So we have the first one, the first model, we have the external model. Okay, so the top model, we have the external model, this one up here. So this external model is the end user's view of the data environment. It's the end user view of the data environment. So it can be many different models. So for here, the term end user, the term end user, this one, term end user here, it refers to the people who will use the application program, which they use the program or the application to manipulate the data and generate information. So basically the end users here refers to those who use the application and they will deal or they will manipulate data and they generate information from the data. So end users, they usually operate in an environment in which the application that they use has a specific business unit focus. Okay, so why here it says different, can be many different models. So it depends to the environment of the application is being used. So companies, they usually for companies like enterprises, it's generally divided into several business units. They can be a sales, they can be a finance, they can be marketing, and so on. So for your assignment, depending on the environment of the nature of the business that you choose, you should have also these different type of business unit focus. Okay, so that you have more tables to generate in your assignment. So each business unit that you have in the company, it is subject to specific constraint and uh, requirements. Okay, so it depends to the end user capability or the level of their on what data they can access. So each one will uses a subset of the overall data in the organization. So let's say for sales, they only access for sales data. For finance, they only access finance, and marketing only access marketing data. So therefore, end users within those business units, it will view their data subsets as separate from other external models. Okay, so it depends on the business unit within the organization. Like here, you have two external model. So let's assume this one end user view here. This one is a self-representative, so this person will only refer or will only manipulate the data for self data. And let's say, as an example here, this end user, the other end user here, let's assume that this one is from HR department. So this HR department end user will only access the external model of HR data unit, business unit. Okay, so that's why here it's mentioned it can be many different models. It's according to the business unit that the end user can access. Okay, and then we have the next one is the conceptual model. So the conceptual model, it describes what data to be stored, used in an enterprise, in a business, and it's independent of all physical considerations. So basically here, it's the designer view. So this conceptual model, it represents a global view, for the entire database by the entire organization, basically the whole thing, like the global view of the entire database system of the whole organization. Okay, so this conceptual model, it will integrate all the external views, like the entities, the relationships, the constraint and processes. It will combine it into a single global view of the data in the enterprise or in this organization. So that is what happened in this. That is what is being presented in this conceptual model, which is the designer view. So the most widely used conceptual model in database environment is the entity relationship model. Okay, so remember in your assignment you also need to produce this ERD. So the ERD, entity relationship diagram, it's used to graphically represent the conceptual schema of your database design. So you need to so the phase that you need when you want to design your database, first you need to identify your end user. Of course, your end user requirement, which is the problem. What are the requirements of your end user? And then what are the external models? What are the business units that is available in your company or in your organization that you pick, like library? What are the business units for car company? What are the business units? You determine all that. Then you go to the conceptual model, which you will represent the entity relationship diagram, which will describe all the relationship, the entities, the constraint, and also the processes. So for this conceptual model as well, it's independent. Okay, it's independent of both software and hardware. So software independence here, it refers to that this model does not depend on the DBMS software that is used to implement the model. So it's the basic idea on how the database will be presented to the designer view. And then the hardware independence here means that this conceptual model, it does not depend on the hardware used in the implementation of the model. So therefore, any changes that is made to either hardware or software on the system, it will not have no effect on the database design at this conceptual level. Okay, so that's what it means by this independent of all physical consideration. So it's not dependent. Any changes that you made in your database environment, like the software you change or the server itself you change, the hardware you use on this level, it will not affect the conceptual model. Okay. So next we have the internal model here. So here is where the DBMS view is, internal model. So it's the representation of the database as seen or as viewed by the database management system itself. So in other words, the internal model, it will require the designer, the database designer, which is you, to match the conceptual model characteristics and constraints to those of the selected implementation model. So here is where you match um, the external model and the conceptual model in order for you to have this DBMS view, the internal model. So here is the representation of the database according to what the DBMS can see. Okay, so we have, it's similar to what we have discussed previously in our previous lecture. So if you can check again our previous lecture on how the internal model look like, internal view. Okay, internal view. This one, yeah, internal or physical level. So it's similar to that. So in database model, in this database modeling, we have another one model. It was extended, the view was extended. So we have the physical model. So this physical model, it operates at the lowest level of the abstraction of data model. So it describes the way data is saved on the storage media, such as the magnetic or is it solid state or optical media. Okay, so the physical model, it requires the definition of both physical storage device and also the physical access method that's required to reach the data within the storage device that's available in the organization. So this makes it both software and hardware independent. Sorry, software and hardware dependent. Okay, it's dependent. So it differs with conceptual model. So in conceptual model, it's independent of software and hardware. But for physical model, it's software and hardware dependent. Okay, so I repeat why it's software and hardware dependent. So this physical model, it requires both the physical storage devices and the access method that is required to reach the data within the storage media or storage device that is used in this particular organization. So the storage structure used are dependent on the software. So the software here is referring to the DBMS and also the operating system on your hardware. And on the type, it also dependent to the type of storage devices that the computer can handle. Okay, so please remember, conceptual model, it's independent against software and hardware, while for physical model, in this database model, it is software and hardware dependent. So it refers to the storage device that is used for the database design. Okay. So according to this NSI Spark architecture and database design, there are three phases of database design. So we have the conceptual database design, the upper view, the external plus conceptual, and then we have the logical database design, and then we have the physical database design. So the logical database, the logical design here, it's together with the conceptual database design. So here is the stage where the design phase that it matches the conceptual design to the requirements by the end user of the selected DBMS, and this logical design is used to translate the conceptual design to the internal model for selected database management system. Okay, so from the logical design, you decide what what is the internal model according to the selected database management system. It can be SQL Server, it can be Oracle, or etc. So for our practical, we're using Oracle, the free version, which uses SQL queries as using SQL Plus. Okay, so that's the DBMS view. So basically, what we see on during our practical, during our practical session, we are looking at internal model, which is the DBMS view of our database. Okay, so that's all for database model. Data modeling. So next we go to the next part of this lecture. We look at the entity relationship model. Okay, so this is another model in data modeling. So we have this entity relationship model. So first, let's look at the first keyword here, the entity. So what is an entity? Okay, so before that, the basic building blocks of all data models are this red font here, red. So we have the entity, attributes, and relationship, and also constraint. Okay, but we don't discuss constraint here. We discuss these three. So these are the building blocks of all data models. So this one is referring to entity relationship model. So what is an entity? So entity is a distinguishable object that exists. It can be a person, it can be an item, it can be a thing, it can be an event, it can be a place. So it's where data is collected and stored. So basically, it's the concept in the user environment about which the organization wishes to maintain data. So each entity occurrence is unique and distinct. Okay, it's unique and distinct. So here we have, like example, here we have entity like customer, we have entity of supplier. Okay, so for customer, let's say, for example, a customer entity, it would have many distinguishable customer occurrence. They can be like John Smith, they can be Noel, they can be Ferrer, they can be Alvin, they can be Ivan, Celine. So all of you are different entities, right? So all of you will have different characteristics. You have Russell, you have Jeremiah. So all of you are a person. You are a unique entity, a person. All of you have different name. They can be same name, okay, but you will not have. That's why we all have our unique ID, our identity card, and also your addresses will be different, right? So that's what makes you distinguishable. That's what makes you unique. But of course, everything that makes the thing that really makes an entity is unique in database environment is the primary key of that particular model, that particular table. Okay, so for customer, maybe you have customer ID as the primary key, so that is what makes it unique. Okay, so entities, it can be physical objects as well, and but also entities, it can also be may also be abstractions like flight routes, or maybe can be musical concert as well. So as long as it's a distinguishable object that exists in your database system. Okay, so next we have the attribute. Okay, what is an attribute? So an attribute here refers to the properties of or characteristics of an entity. Okay, so you as the entity, like just now I mentioned all your names. So your attributes are your characteristic, like what's your full name, what's your first name, what's your last name, what is your address, what is your age. So all those are the attributes of you as a person, right? So if you are the entity, your attributes are your characteristics. Okay, so in this example here, customer entity here, a customer entity here, it would be described by attributes such as the customer's last name, the first name, the phone number as well, and then it can be the address, maybe also credit limit, for example, like if your organization have like what you want to set transaction with a credit card, okay, you can set also the credit limit of the customer. Okay, so next, so we have the entity, and each entity will contain a set of attributes which explain the properties or the characteristic of an entity. And then come next the relationship. Okay, so what is relationship here? A relationship in an entity relationship model, it refers to the association among several entities. Okay, so you have customer, order, product, all these are entities. So if you see the connection here, all these are relationships. Okay, so for example, like a relationship can exist between a customer and order, and order entity can have relationship with product, and so on. Okay, so another example would be a relationship can exist between customers and agents. Can be described like an agent can serve many customers, and each customer may be served by one agent. So it can be one to many or one to one. So data models for entity relationship model, it usually uses three types of relationships. Okay, so it can be one to many, can be many to many, and it can be one to one. So depending on your uh, your business units, your conceptual model as well. Okay. So next, this is the view of a basic entity relationship model. So here, the first one here, we have the entity model, or sorry, entity symbols, or also the entity types. So this one, I think this one is referring to Microsoft Visual. So there is a meaning of this box here. In this one, it's square. This one also have meaning. Okay. So for this particular ER model, this represent a special entity that is also a relationship. Like if it's using this shape. Okay. And then you have the attribute symbols. They usually look like this. So you have the entity name, you have the identifier, partial identifier, and so on. And then we have the relationship symbols. Okay. So we have unary, the relationship degrees. We have unary, binary, ternary. So unary relationship exists when an association or an entity is maintained by a single entity. Then binary, usually when there are two entities associated. Okay, so there are two entities here. And ternary, when there are three entities associated. Okay, so relationship degrees, it specify number of entity types that's involved in the database system. And then we have another term here, relationship cardinalities. So here, relationship cardinality. So it specify how many of each entity type is allowed. Okay, so if you see this one, this symbol, it is mandatory one. And then if you see this symbol, mandatory many, and this symbol optional one and optional many. Okay, so if I'm not mistaken, this is a Microsoft Visual symbol. Okay. So this is just to show you the basic ER models. So you just need to understand there are symbols that you need, yeah, that you can use to represent your ERD, your entity relationship diagram. Okay. So for your assignment, you can either use all these symbols or you can use other type of symbol, but as long as you just can just define the symbols that you use in your ERD. Okay. Okay. So before we proceed to this one, we take 5. Okay. Okay. Can we continue? Okay, continue. Yeah. So now we look back at the early data models that we discussed just now, the figure that we discussed just now on the early data models. So we have the first one, which is the hierarchical model. So this hierarchical model is represented by an upside down tree. Okay, upside down tree. So it means that you have a root and then you have branches down here. So that's why it's called upside down tree. So the root is at the top and the branches and the leaves are at the bottom. Okay, so that's why it is called upside down tree. So this is the early database model whose the basic concepts and characteristics form the basis of the subsequent database development later after over the years. Okay, so this model is based on this upside down tree structure, which in this database model here, each record is called as a segment. Okay, so it contains level of segments. So each level will have the, so this is the top one is the root segment, as you can see here, and then each segment will have a one to many relationship to the segment directly below it. So you have root segment 1 to level 1 segment. Okay, so you have 3 here, so it's 1 to many. Okay, 1 to many means you always have 1 to many relationship in this hierarchical model. So these are the level 1 segments. So it's the root children. So you have 3 here, and then you have level 2 segments, which represent the level 1 children, okay, and then level 3 segment and so on. Okay, so you have root segment, level 1 segments, level 2 segment, and level 3 segments. So a segment is the equivalent of a file system record type. So within the hierarchy, the higher layer of this model, it is perceived as the parent. Okay, so you have the children. So typically the root segment, which is the top level or top segment, is the parent of all, and then you have the level 1 segment these are the parents for level 2 segment. Okay, so each parent can have many children, but each child has only one parent. Okay, so in this situation, one parent can have many children, but these many children can only have one parent. Okay, so I repeat, each parent, so this one is a parent for this segment. So it can have more than one children, so it's one too many. And each child here can only have one parent. Okay, so similar to the bottom here, this level 3 segment. So the children here can only have one parent, similar to this part, one parent. But the parent can have more than one. It can have more than one children. Okay, so it's one to many relationships between a parent and its children segment. So this is for hierarchical model, and the next down to the after we have this hierarchical model, then there is a network model. Okay, so the network model was created to represent complex data relationships more effectively than the previous model, which is the hierarchical model. So this is to improve database performance and to impose database standards. So this in this network model, the user perceives the network database as a collection of records. Yeah. So collection of records in one-to-many relationship. Yes, but it also supports many-to-many relationship. Okay, if you notice here, the invoice has many. The invoice line also has many, so it can be many-to-many, but typically it is a collection of records in a one-to-many relationship. So unlike the hierarchical model, the network model, it allows a record to have more than one parent. Okay, so it allow it allows a record. So in this case, we call it a record. It can have more than one parent. Okay, so like this invoice, it can have these two as the parents. Okay, so invoice can have customer and sales rep as its parent. So there is limitations of these two model that we discussed just now, the hierarchical and also the network model. So the limitations or the disadvantages are the data are stored in rigid and predetermined relationships. Okay, so it's one-to-many or it's many-to-many. So there is no database dictionary language existed, no DDL existed, database data dictionary language existed, and changing the structure of the data was difficult, and it also lacked of a simple query language, which hindered application development using these two models. Okay, so that's why next we have the relational model. Okay, so we have the relational model. So this relational data model, it typically represents data in forms of tables. Okay, so it is represented by a collection of tables. So these tables, each table will have, it has a number of columns with unique names, which called as attributes. Okay, so we have the table name, and then we have the columns with unique names, which is the attributes of this table. And then we have the degree here. The degree is the number of attributes in a relation. And then we have the cardinality, which refers to the number of tuples in a relation. So cardinality is basically referring to the rows, okay, number of rows. This cardinality refers to the number of rows. The tuples are referring to the rows according to the columns that we have for this cardinality. Okay, so these are the characteristics of a relational model. So in this relational model as well, user will see the database as a collection of tables in which data is stored. So each table is independent from another. The rows in different tables are related based on common values in common attributes. Okay, so here we have the common attributes for this example. Here we have the branch number, and it's the foreign key for this staff table. So this is what we call it means to this common attribute. So you have the branch number attribute related to the staff table, because the branch number is included in this other table as the foreign key. Okay, so it's independent from one another. Each table is independent from one another, but they can be relationship based on common values if you have a common attributes in different table. Okay, so let's now look at the integrity constraint that we can apply to a relational model. So the first one, we have we have several types of constraints in this relational model, or it can be also it is also known as the rules that limiting acceptable values and actions that which the purpose is to facilitate maintaining the accuracy and integrity of our data in the database. Okay, so there are three basic types. So the first one is integrity towards entity integrity, and then we have the domain integrity, and the third one is the referential integrity. So for your in our practical also we already do this, we already discussed about this, not in detail, but we already look at what is the purpose of primary key and also the domain integrity as well as the referential integrity. We have done this in practical too, some of it. Okay, so let's discuss on each one of these. So the first one is the entity integrity. So entity integrity rule is designed to ensure that every relation has a primary key. Every relation has a primary key. So it is not allowing multiple rows to have the same identity within a table. So this every relation must have a primary key, and that the data values for the primary key are all valid. So usually we put this primary key attribute as non-null. Okay, not null. So in our SQL query, we type it as when we declare an entity to be a primary key, we must declare it as not null. Okay, primary key is always not null. So primary key of a table, it must contain a unique non-null value for each row. So that's for entity integrity. It refers to the primary key. So the next integrity constraint, we have the domain integrity, which is restricting data. So in this domain integrity, all of the values that appear in a column of a relationship must be from the same domain. So a domain here is the set of values that may be assigned to an attribute. So a domain definition, it usually consists of domain name, the meaning, the data type, the size, and allowable values or allowable range. So you can, using this domain integrity, you can set allowable values. For example, like here, you create a domain name as a price change. It must be as decimal. So the data type is decimal. So, and then you check. Okay, so this is where the domain integrity, when you use domain integrity, so you check the value must be between this value here. Okay, so we also have done this in our previous practical, where we check for the, if I'm not mistaken, the salary. So you do this, and for the exercise for practical 2 also, you also should be doing this domain integrity, which you do the check. You assign value that is allowable in your database. Okay, so in your assignment also you need to apply all these check constraints. Okay, you need to also include this. And then the last one, the third type of integrity constraint here, we have the referential integrity. So this referential integrity requires the existence of a related row in another table. So remember we do last week, we alter the table because we added a new table, and then you want to declare a foreign key in in your table. Okay, so here you have these two tables here. You have the customer table and you have order table. So here you in your query, you need to declare the customer ID, as a foreign key in this order table with reference, reference to the table customer. Okay, so remember we have done this in our previous practical. Okay, so that these are the three basic types of integrity constraints. So you can use this to apply in your assignment as well. Okay. So next we have, okay, so the next one we will discuss on object-oriented model. So object, this one also known as OO, okay, OO. So the object here is it's referring to an abstraction of a real world entity. So in a general term, an object, it may be considered equivalent to an entity relationship models entity. Okay, so an object, here the object, it can include information like the attributes, the state, the operations, the behavior, and also the identity. So the attributes or state here, it refers or it describes the properties of an object, like we discussed just now. And then the objects, the behavior and operation, it specify how an object will act and react, and objects that share similar characteristics are grouped in classes. So a class here, it is referring to a collection of similar objects with shared structure. So the shared structure here is the attributes. Okay, attributes. For example, here we have the attributes here for students, and behavior is the method. Okay, so the list of operation is the method, what it can do. Okay, so we have the class name as the entity, and then or the object, and then we have the attributes here, and then the list of operation, what are the operation that this entity can do. Okay, so these two, when it like relate to each other, so here you register for course and you enroll, so you will get the another entity, which is the course registered, course code, this one, course title, and the credit hours. So this is how object-oriented model look like. Okay, basically it will show you the name of the object, the attributes, and the behavior or the operation that you can do for that particular object. Okay. So next, still in object-oriented, so classes are organized in a class hierarchy. So this class hierarchy, it resembles an upside down tree view, okay, upside down tree view, in which each class here will have only one parent, okay, one parent. And then we have inheritance in this object-oriented model. So inheritance here is the ability of an object within the class hierarchy to inherit attributes and methods of the classes above it. So basically, the children inherit the attributes of the parent. Okay, so you see here, you can see the attributes. Here the behavior, and here also constructors, calculate salary, double. So it also it inherits from this employee table here. Okay, so these are another characteristic of an OO model. In OO model as well, we have aggregation and composition. So aggregation here is the process of transforming data from a detailed level to a summary level. So here you can have more than one student. So you can view the, according to OO model, you can do aggregation where you transform a detailed level of data to a summary level. Okay, so you can have more than one representation here, but you aggregate it into this view. And then composition. So compositions, it describes a class that reference one or more object of other classes in in the environment, in the database model, in the object-oriented model. Okay, so aggregation, you transform detail level to summary level, and composition, you describe a class, okay, that refers to one or more object of other classes. So here, student class, it refers to name class. Okay, so in this example. So that's for our model. Next, we have the UML. Okay, UML stands for Unified Modeling Language. So this is the modeling language. So this is the diagram that is used to represent object-oriented modeling. So it looks like this. Okay, so something like this. You have the classes, you have the relationship, and also you have the parent and child as well. So this UML, it's a language based on object-oriented concepts that provide tools such as this diagram and symbols to graphically model a system. So this is a system of university. Okay. So why do we want to use object-oriented? Okay. So conventional data models like relational model it's inadequate. It cannot model complex data and unstructured data. It cannot also model processes or process dynamic behavior like for OO. We can look at the behavior, the state of the processes or the entity, and it does not support reuse as well for relational. So object-oriented model, it's more natural way to represent the real world. So that's for OO. And then we have the last part of the models that we have, the models that we have in data modeling. So first, let's look at structured data first. So structured data, usually it's represented in a strict format. Okay, strict format, like you have the branch number, you have the street, you have the city, and you have postcode. Okay, it's only text, right? But in a big data context, variety refers to the vast array of formats and structures in which the data may be captured. So data can be structured, it can be semi-structured as well. So it can be unstructured also. Okay, so in semi-structured data, it has a certain structure. The structure may not be rigid, regular, or complete. So the example given here is like a scientific data or e-catalogs which can always change. And then for unstructured data, it is a very limited indication of the type of data. This data those that is not organized to fit into a predefined data model. So example like text document which contain a map, images, sound, and video segment. So here is an example of a semi-structured data. So you have this one for LCD TV. You have the data dish model with all these attributes, display and also projector. It is shown like the model, what is the model, what is the display. Okay, so this is an example of semi-structured data. So for the semi-structured data, it combines elements for some parts of the data that is predefined model, but sometimes other parts do not. So this is the predefined data for this particular LCD TV and also projector. So all these are predefined. Okay, so next we have an example of semi-structured data as well. So this is IMDb. Okay, I think all of you know this site. So this Internet Movie Database, it's a classical example of a collection of a semi-structured data. Although the information pertaining to different movies may be essentially similar, but the structure may be different. So there is an irregularity in structure. Like for example, some movie may annotate information about the actors, the choreographer, the director, and the producer, while another movie they may just put in additional information about the lyricist and the music director on that particular movie. Okay, so there is an irregularity in structure for a semi-structured data model. So this is an example of a movie. So example, an actor's name may be represented as a string, or it can be as a tuple, like you put in as a first name or last name. So when data like this are added into the database dynamically, the structure of the database as a whole will keep changing. Okay, it will keep changing. So here you have like the movie one, the cast is Cruz, the director is also Cruz, and then you have movie three, uh, actors, actresses, direction, so on. Okay, so basically the point here is to tell you that there is irregularity in structure for this IMDb. And then we have semi-structured data model. So it supports JSON and XML. These are the other markup language. So JSON stands for JavaScript object notation. Okay, so these are all forms of semi-structured data. Okay, so you have product. So this is an XML example. And then this is another example of JSON, JavaScript object notation. So it's a human readable text format for data interchange that defines attributes and values in a document. So usually for this data schema here, you see here, maybe you have seen this. It defines validation, documentation, hyperlink navigation, hyperlink navigation, and the validation, interaction control. Okay, so you have it defines the name, the string, name of the product, number, and so on. Okay, so this is an example of a semi-structured model. So what are the advantages of this semi-structured data model? So the advantages of these are it can represent information of data sources that cannot be constrained by schema. So it provides a flexible format for data exchange between different types of databases. So for this semi-structured data model, the schema can easily be changed, so it can be updated. So in comparison with relational data model with XML, so its relational data model is inefficient, where in XML the text it represents schema information and it's repeated. Okay, so if you see here, like from here, you can see like the repeated declaration, and then better than relational tuples as data exchange format. So unlike relational tuples in relational data model, this XML or JSON data is self-documenting. It's non-rigid format and allows nested structure. So, and also it has a wide acceptance, not only in database system, but also in browsers, tools, and application. But typically, this XML and JSON is used for website nested structure, like this one is nested. Okay, so that's about it for this lecture. Do you have any questions so far?
No.
Okay, so I assume everyone understands. So basically, what you need to like take note for this chapter is the type of data models that we have, and also how the evolution of our data modeling, the semantic in data model. Okay, this one, Donna. So you need to understand about the ERD, and then the characteristic of relational model, and this one is the most important one because this one you will apply to your assignment. Okay, integrity constraint, and then ERD as well. You will need to create this for your assignment, and also this one, the data modeling, the view, the external model, the conceptual model, internal model, and also the physical model. Yes, this one. Okay, so you need to try to like understand why there is a changes of this data model from hierarchical to up until NoSQL. Okay, but today we have looked at hierarchical, network, relational, the ERD, and also OO. Okay, OO is under semantic, and of course the definition or the description of data models, data modeling. What is data modeling? Okay. So if you have no more questions, that's it for today. Thank you so much, everyone, for your attendance and um, for your participation in this lecture session. So I'll see you again tomorrow at 4 p.m. for our practical replacement. Tomorrow kan? Correct kan?
Yes.
Okay, so I'll see you again tomorrow for our practical session at 4 p.m. Thank you so much, everyone, and have a nice day. Thank you.
Okay, Miss. Thank you.
Okay.